All right, 7.6. We're going to be talking about the inverse of a square matrix. So more specifically, a 2 by 2 matrix. We're going to be finding the inverse. So our inverse matrix is this matrix here where it's got a diagonal of 1s and 0s. We're going to be verifying that two matrices are inverses of each other. We have to multiply A times B and B times A, and the result for both of these is going to give us the inverse matrix, which again is the diagonal of 1s and 0s. So let's multiply. Here we have to multiply A times B and B times A because the order matters. So when we multiply A times B, we're moving in A with rows and B in columns. So the first row times the first column, we multiply the first number times the first number. So 1 times -1 would be what? -1. The second number times the second number would be 2. And -1 plus 2 is 1. So then let's do the first row, second column. -1 times -2 would be +2. 2 times -1 would be -2. And 2 minus 2 is 0. Now let's do the second row, first column. That's going to go in the second row, first column spot. So -1 times 1 would be -1. And 1 times 1 would be 1. -1 plus 1 is 0. And then we can do second row, second column. -1 times -2 would be 2. Plus -1 times 1 is -1. So 2 minus 1 would be 1. Did we get the inverse matrix? Yes, we got our diagonal of 1s and 0s. Second thing we have to do is check that B times A is also the inverse matrix. I need both of these things to be true. So I'm going to rewrite my order of matrices. I'm going to put B first and then A, which is -1, 2, -1, 1. So I'm just rewriting the order. So now in matrix B, I'm going to move in rows. And in matrix A, I'm going to move in columns. The order matters. So starting with the first row, first column, we have 1 times -1, which would be -1, plus -2 times -1 would be 2, and -1 plus 2 is 1. Then the first row, second column, 1 times 2 would be 2. -2 times 1 would be -2. So 2 minus 2 is 0. Then the second row, first column, 1 times -1 is -1. -1 times -1 would be +1. -1 plus 1 is 0. And then second row, second column, 1 times 2 would be 2. -1 times 1 would be -1. 2 minus 1 is 1. Did we get the inverse matrix again? Yes. So are these inverses of each other? Yes. This is how we verified by finding the inverse matrix for A times B and B times A. It's not always going to be the case that A times B and B times A are the same thing. But when they both give us the inverse matrix, then our matrices are inverses of each other. So we have to follow a couple rules when coming up with our inverse. We have a major diagonal and a minor diagonal. Our major starts in the upper left-hand corner. So this is our major diagonal. We always switch the major. So switch the major, and then our minor starts at the bottom and goes up. So this would be our minor diagonal. We negate the minor. So we make the minor diagonal negative. They stay in the same spot, but they become negative. So we switch the major, and we negate the minor. And then the second thing we have to do when finding our inverse is we multiply by 1 over the majors multiplied together minus the minors. So I'm going to write that here. Major minus minor. So example 4, it says, if possible, find the inverse of each matrix. So I'm going to start by finding what 1 over the majors times the minors are. So our major would be 3 times 2 minus the minors, which is -2 times -1. So 3 times 2 would be 6, minus -2 times -1 would be +2. 6 minus 2 is 4. So this gives us 1/4. So 1/4 is going to be our scalar. Now we multiply that by our new matrix. So with our new matrix, we do what to the majors? Switch the majors. So instead of it being 3, then 2, we're going to switch it to 2, then 3. And what do we do to the minors? Negate. So since they're both negative already, we're just change the signs and make them positive. So they stay in the same spot, we just flip the sign. So it turns into +1 and +2. The very last thing we want to do is distribute our scalar to everything. So 1/4 is going to get distributed to everything on the inside. So 1/4 times 2 would be what? 1/2, awesome. 1/4 times 1 would be 1/4. 1/4 times 2 is 1/2. And 1/4 times 3 would be 3/4. So this would be our inverse. And we have to write the little inverse symbol, which is a to the power of -1. So we've done inverses before, but with equations. We would name them the same way with that little -1 symbol. So we're just saying this is the inverse of A. Let's do B on the next page. So first, let's find what our majors minus the minors are. So we have 1 over 3 times 2 would be 6 minus 6 times -1, which is 6. What's 6 minus 6? Could I get 1 over 0? What is 1 over 0? Undefined. Since this is undefined, we don't have an inverse, so there is no inverse. So if you get undefined when you're coming up with your scalar, you have no inverse. All right, last one. Let's do example 2a. So we multiply majors minus minors. So 1 times -3 would be what? -3 minus the minors, which would be -1 times 4. So -4. This turns into a plus. So what's -3 plus 4? 1. What does 1 over 1 simplify to? 1. So our scalar would just be 1, which makes it a lot easier because now we don't have to multiply by anything. So then we have to come up with our new matrix. What do we do to the majors? Switch the majors. So when we switch them, they switch positions. So we get -3 up top and 1 on the bottom. What do we do to the minors? Negate. So we flip the sign. So it now turns to -4 and +1. Don't forget, you always want to distribute your scalar, but what was our scalar here? 1. So it stays the same. So this would be our inverse. 7.7 kind of goes hand in hand with our inverse matrices. We want to find the determinant. We can find the determinant of a 2x2 matrix or a 3x3 matrix. Our determinant is always major minus minor. So when we were finding the inverse, we were multiplying by 1 over the determinant. So we were finding the determinant in that last section without even knowing what it is. So our determinant is major minus minor. So for example 1a, our majors would be 2 times 2 minus minors, which is 1 times negative 3. So we get 4 minus negative 3. So this turns into 4 plus 3. What would our determinant be? 7. The most common mistake that people make with these questions is that they flip the order. They mix up the major and the minor. They do minor minus major. But remember, it's major minus minor. Think alphabetically. Major, M-A, comes before minor, M-I. Major minus minor. Let's do B. So majors, again, start at the top. We've got 2 times 2 minus minors, which would be 4 times 1. So we get 4 minus 4, which is 0. So our determinant would be 0. Lastly, let's do C. Majors start at the top, so we get 0 times 4, which would be 0, minus minors. What is 2 times 3 halves? 3, awesome. So 0 minus 3 would be negative 3, perfect. So finding the determinant of a 3 by 3 matrix, the first thing we always want to do is rewrite the first 2 columns on the outside of our matrix. So our first 2 columns would be these 2. I'm going to rewrite them on the outside here. So my first column is 0, 3, 4, and my second column is 2, negative 1, 0. So we always rewrite the first 2 columns. Now the next thing we do is still follow that major minus minors. However, here we've got 3 majors and 3 minors. So I'm going to write that again up top for us. Major minus minor. So our majors start up at the left top, and it'd be the diagonal there. So our majors have 3 numbers here, but again, we've got 3 majors. So we multiply the 3 numbers in each major together, and then add up all 3 majors. So major plus major plus major, minus minor plus minor plus minor. So what is 0 times negative 1 times 1? By 0. Awesome. Plus, what is 2 times 2 times 4? 16. Awesome. 2 times 2 would be 4, and 4 times 4 would be 16. Plus, what is 1 times 3 times 0? 0. Perfect. So our majors, when we add them all up together, would be 16. Minus minors. So be careful because we are still adding up all the minors together, but we're going to subtract from the total minors added together. So minors start up or start down at the bottom corner and go up. So again, we have 3 minors. So we multiply the 3 numbers in each minor together. What is 4 times negative 1 times 1? Negative 4. Plus, what's 0 times 2 times 0? 0. Plus, what's 1 times 3 times 2? 6. Awesome. So I would always recommend adding your 3 minors together and then subtracting at the end. Don't worry about distributing the negative. We're just going to keep that as a minus, and we'll add all three of our minors together. What's negative 4 plus 0 plus 6? What is it? 2. Awesome. So then our majors minus minors would be 16 minus 2, which is 14. Awesome. Any questions? All right, there will be a web assign. It won't be very long, but right now there are 2 web assigns for 7.6 and 7.7. I'm going to put them together into one shorter web assign, so don't do the individual 7.6 and 7.7. I'm going to put them together, so give me a minute to do that, and that'll be your homework for tonight. Any questions on what we did today? Perfect. Yes. Yes.
So I was doing this question.
Mm-hmm.
Did I do it right?
So did you add them together? Yes. So negative 3, 6, 0. That should be 1, positive 1.
Okay.
So positive 1, 0, 4. Okay. And then you divided by 2.
So then I multiplied by that.
Mm-hmm. So negative 2.
So it was literally just, instead of that one, it was positive.
Yeah.
1/2.
Uh-huh.
Okay.
So the rest should be right.
And then for this one, did I do this right?
So you added 4a to the other side. So you found
It's
2b.
2b,
Uh-huh.
and then plus 4a.
Mm-hmm. Then I would add them together. So like get rid of the 1/3 here, add these 2 together, and then divide by 3 at the end.
So then I would combine these 2 into one matrix,
Mm-hmm.
and then.
And then.
Okay.
Yeah.
Thank you.